Good morning to all. Today we will learn about skewness. After this class, we expected the learners may know the meaning of skewness in statistics, meaning of positive and negative skewness, various measures of skewness, and use of skewness. Now we have learned about the skewness. So before going to this concept, you may know symmetry. Symmetry. Symmetry means, suppose you have plotted the given distribution basing on the given data, you may are getting more or less the bell-shaped curve, more or less the bell-shaped curve. Then we said that distribution is a symmetry. That distribution is a symmetry. At the same time, where this the maximum height of the curve, where locates mean equals to median equals to mode. Mean equals to median equals to mode. At the same time, how many observations under the left hand side exactly equals to the number of observations under the right hand side. So this is nothing but symmetry. Symmetry. So let us know about the skewness. Skewness means, literal mean is lack of symmetry. Lack of symmetry. Right? So now, what are the characteristics of a skewness or skewed? So one is we have to identify mean, median, and mode or fall at different points. The second point we have observed under the skewed distribution is quartiles Q1, Q2, Q3. So Q2 already know, which is nothing but the median, which are not having equidistance. The third one is suppose you may be draw a curve frequency distribution basing on the given data. The sides of the curves are stretched more than the other. The sides of the curves are stretched more than the other. So these three characteristics we have observed in any skewed distribution. So now let us know how it is nothing but, suppose the curve may be right hand side like stretcher. In the similar manner, this is already you know that. And one more right. So this is right hand side. The tail of the curve right hand side is more stretched than the left hand side. So this is called positive skewness. Positive skew. This is, if you observe that one, this is nothing but symmetry distribution. If you observe, the left hand side of the curve is more stretched than the other. This is negative skewed. Now you observe in the symmetric distribution, mean, median, mode are coincide, are located at the same point. But whereas in this, if you observe that this is nothing but mode value, so where it is nothing but median value, and where this is nothing but mean value. In the similar way, here also this is mode, this is mode, and this is nothing but median, this is nothing but mean. This is nothing but mean. So this is the location of the mean, median, mode in positive and negative distributions. Positive and negative skew distributions. Right. So now positive skewness is nothing but if the larger tail of the distribution, lies towards the higher values of the variate, that is right hand side is known as positive skewness. Similarly, if the larger tail of the distribution lies towards the higher values of the variable that is left hand side is known as negative skewness. So by diagrammatically, by inspection method, we have to know whether the distribution is symmetry distribution or skew distribution. If it is a skew distribution, whether it is a positive skew distribution or negative skew distribution. So now how can measure? So now we have to learn measures of skewness. So various measures are there, like measures of dispersion, absolute measures also there, relative measures also there. We know that absolute measures are not useful for comparison purpose. Relative measures are only useful for the comparative purpose. That's why in reality, most of them are using relative measures for measuring the skewness. So here also we have to discuss the measures. The first one is Carl Pearson's coefficient of skewness. Right? So which is given by SKP equals to mean minus mode by sigma. Mean minus mode by sigma. Right? This is nothing but Carl Pearson's formula. So here mode value. If mode is ill-defined, then we have to calculate Carl Pearson's coefficient of skewness by using the interrelationship between mean, median, mode. So we know that mode equals to 3 median minus 2 mean. 3 median minus 2 mean. If you substitute, the above formula becomes 3 into mean minus median by sigma, right? 3 into mean minus median by sigma. So this is nothing but Carl Pearson's coefficient of skewness. If you observe this coefficient of skewness, which depends on only mean, median and standard deviation. And the above measure is depends on mean, mode and standard deviation. Right? So suppose to be any distribution, you have to calculate mean, mode and standard deviation and substitute in this formula. You may getting SK equals to 0. That is Carl Pearson's coefficient value equals to 0. Then you said that distribution is a symmetry distribution. Right? So if you are plotting the given data on a graph paper, you are getting more or less well-shaped curve. bell-shaped curve. Suppose it may be a positive value, that is greater than 0. Greater than 0, that is positive skewed. Positive skewed. It is a negative less than 0, that is negative skewed distribution. Right? This is the interpretation of Carl Pearson's coefficient of skewness. Carl Pearson's coefficient of skewness. So if you observe that one from these two formulas, if it equals to 0 means mean equals to median equals to mode. Mean equals to median equals to mode. So what we just now said, the characteristic of symmetric distribution is mean, median, mode coincide, right? The second formula, Bowley's coefficient of skewness. Bowley's coefficient of skewness. Bowley's coefficient of skewness. So this is given by Professor Bowley has given by SKB equals to Q3 plus Q1 minus 2 median by Q3 minus Q1. Q3 minus Q1. So if you observe that one, this formula based on first quartile, third quartile, median is nothing but second quartile. So the entire formula given by the Bowley depends on the quartiles. That's why this has another name, quartile coefficient of deviation. Quartile coefficient of deviation. Quartile coefficient of deviation, right? So here also suppose to be the distribution is positive skewed distribution, then Q3 plus Q1 is greater than 2 median. Q3 plus Q1 is greater than 2 median. Suppose negative skewed distribution, Q3 plus Q1 is less than 2 median. The another measure is third measure for measuring the skewness, Kelly's coefficient of skewness. Kelly's coefficient of skewness. So Professor Kelly has given the formula for measuring the skewness. SK equals to P90 plus P10 minus 2P50 by P90 minus P10. So where P90 and P10, P50s are nothing but percentiles. Similarly, basing on the deciles, D9 plus D1 minus 2P5 by D9 minus D1. So where D is nothing but deciles. So Kelly's formula based on percentiles or deciles. So another formula is also there, which is based on moments. Skewness based on moments. So SK equals to square root of beta 1 into beta 2 plus 3 by 2 into 5 beta 2 minus 6 beta 1 plus 9. So here in the last video, if you observe that one beta 1, beta 2 are called beta coefficients, which was given by Professor Carl Pearson. This coefficient of skewness, based on beta coefficients. So already you know that beta 1. What do you mean by beta 1? Beta 1 equals to mu 3 square by mu 2 cube, mu 3 square by mu 2 cube, and beta 2 is nothing but mu 4 by mu 2 square, mu 4 by mu 2 square, mu 4 by mu 2 square. If you substitute those quantities in this, if you are getting Sk equals to 0, that means this measures of skewness value is 0, then you said that distribution is a symmetry distribution. Otherwise it is a skewed distribution. If you are observing this one, which becomes 0 means either square root of beta 1 equals to 0 or beta 2 plus 3 equals to 0. So the second quantity, if you observe that one, beta 2 equals to minus 3, which means that negative value. It is not possible beta 2 value getting the negative value. Why? Because of mu 4 is positive, mu 2 square is also positive. That's why beta value always may be positive. So this is the contradiction of the principle. That's why only the possibility is beta 1 equals to 0. Right? So, but this measure is called absolute measure of skewness. So, in practical situation, in reality, we may not be decided the given distribution is a skewed distribution basing on beta coefficient, especially beta 1. So we have to calculate gamma 1. Gamma 1 is square root of beta 1. We know that. So basing on that gamma 1 and beta 1, we have to decide whether the given distribution is a positive or negative distribution, negative skewed distribution. Right? I hope you understood the four measures of skewness. And what is the importance and use of the skewness is by using the skewness, we have to know the nature and shape of the distribution. Most of the testing of hypothesis, most of the large sample or the small sample test, basing on the fundamental assumption of the samples of the population drawn from the normal population or normal distribution. Right? If that assumption holds good, then that distribution is a symmetric distribution. That's why the measures of skewness play a vital role in statistics to know the nature and shape of the distribution. Thank you for watching this video.